Okay, so you might be wondering, why doesn't the mass of the planet affect the velocity of the planet and the path that the planet takes around the sun? It's a really good question because we found out that the mass of the planet actually does affect the gravity force, the centripetal force. So you might expect, well, when we were talking about circular motion earlier, we saw there was a relationship between velocity and centripetal force. And you're exactly right. So in order to explain this, we need to go through some math. So we're going to go back to that original equation for the velocity of an object moving in circular motion, which was the force centripetal equals the mass of the object spinning times the velocity of the object squared divided by r. So this was when r was our distance and here was our mass, and this was going around in a circle at some velocity v. Now we have a new equation that we just introduced, which is the force of gravity in this case is equal to m of our sun, or actually I'm going to call this m, 2m1 over r squared times this constant g. So now our situation looks a little bit different. We have an m2 in the middle, we have an m1 on the outside, and this is orbiting around at some v. So similar, but now we have an object in the middle. I'm going to set these equations equal because we know gravity is our centripetal force. Fg is our Fc in this case. So I'm going to set these equations equal to each other. And we get m, and this m is the same as m1 in this equation. So I'm going to say m1 v squared over r equals m2 m1 over r squared times g. And now our m1s cancel out. We have one r that cancels out. And we end up with v squared equals m2 over r times g. V equals the square root of m2g over r, which was the equation for velocity they introduced in the last equation. So now you can see where this comes from, and you can see why the mass of the planet actually does not affect the velocity. It's because of this mathematical law that is behind all of these forces. Okay, so this explains why it doesn't affect our velocity, but why doesn't it affect our orbital shape if it is clearly affecting the centripetal force being felt? And this has to do with this model. So like I said at the beginning of the series of videos, this is not a scale model. This is not really what it looks like in real life. To understand that, we have to go to this model. So this would be more like what it looks like, just dots. Like the planet is so small compared to the star, and they're so far apart. And so actually this gravity force acting on it has a lot to do with the relative masses of the stars and the planet. And so let me just clear some space over here to talk a little bit about this. Da-da-da. So we learned earlier on that this gravitational force is m2 m1 over r squared times g. So the mass of the sun, although in our model looks like they're kind of similar, the mass of the sun is actually way bigger than the mass of the planet. And so as you change this, so you make it bigger or smaller, yes, you're changing this gravitational force. And yes, that's true. But when you change this value, it's so small compared to m2 that it's really not affecting Fg that much. So this explains why, even though velocity is staying constant, even though our gravity force is changing, it's not changing that much because the mass of the planet is so much smaller than the mass of the sun. Okay, so hopefully that helps you if you were wondering about that.